When they sent me this board, they just sent me the board.
Yeah.
No
Okay,
documentation, no explanation, anything. I didn't know what it was.
Yeah.
So I just thought it was a microcontroller, and I didn't know really what to do with it.
Okay.
I plugged it into a different monitor, and nothing happened. I'm like, what is happening here?
This way, okay, this is looking, we are looking at the face. Okay, it can detect the two people face. Yeah.
What's the green things showing?
It was thinking this is a time.
Okay.
But
only
it's
50%.
Yeah. It's green. It's green. It's running. Docker PS. Docker is nothing.
Yeah, and honestly, the CPU that is using is probably you right here looking at it. It's not even using the CPU here because it's just all in the microcontroller.
Yeah, it's MCU is running that, so we don't need the Linux.
And so Qualcomm's not going to do a tiny little microcontroller. They're going to do a big, fat application processor.
Let's right into what's juicy part, which is like you bring us some surprise.
Yeah, so I brought with me the new Arduino Uno Q. So this is, I don't think it's out for a couple weeks maybe, but I was lucky enough to get my hands on one. I think this is one of maybe like 20 prototypes that were made before the production run. And so I've been playing with it for a couple weeks, and I just thought of you guys when I was playing with it because it has the ability to connect remotely for your, over Wi-Fi, or you can plug it in via USB. But it can also, unlike any other Arduino before it, this is a fully blown single board computer that you can plug a mouse and a keyboard and a monitor into. But when I tried to do that the first time, I plugged it into a monitor and nothing happened.
Okay.
I plugged it into a different monitor and nothing happened. I'm like, what is happening here? So then I thought, you know what I should try? I'll use your guys' KVM and see if that works.
Right, yeah.
And that works, so I was able to use it.
We're going to try that. I mean, that setup. And actually, just the day before yesterday, I mean, Kevin had the chance to try that. Yeah, look into it. So we already tried, and it does work. And I think it's great. So right now, let's maybe look at the details, suspect a little bit, and then see why they decided like that. To be honest, I mean, at the beginning when you told me about that Uno Q, I mean, I like what? I mean, I have no idea how come it sounds like something completely different.
Yeah, I think that was intentional. I mean, when they first told me about the project, maybe in July, they kind of didn't tell me a lot of details. They said it was going to be the same shape as a normal Arduino. They were calling it Project Imola back then, and I didn't know what that meant. But they just said it's going to be something totally different, unlike anything we'd done before. But like, didn't really know much else about it. And I started making some guesses. But then when they sent me the actual board, and I saw the Q on there, I'm like, you know, what does that mean? Like, it's not Uno R5. Like it goes Uno R3, Uno R4, and it's not R5. So it's different, even though it's got the same matrix on here and the same kind of look. But there's a lot more chips on here, and on this side there's a whole bunch of new stuff, the high density connectors and things like that. So anyway, the Q was the clue into what was happening in a larger picture, which was I was at an event in Turin a couple weeks ago where they announced, in addition to this board and the new App Lab software, that Qualcomm is acquiring Arduino. So I think the purpose of this board is to act as sort of a showcase of that partnership.
Right.
And so Qualcomm's not going to do a tiny little microcontroller. They're going to do a big, fat application processor. And so that's why the single board computer form factor, I think, is what they were. That's how this came together like that.
Yeah. So what do you think, Kevin? I mean, the chip they using right now for Qualcomm, they can run Linux right now.
Yeah, they can Linux. Well, they are actually running a Linux and another MCU on it because look into their spec. They are running STM32. And another is they run a Debian Linux on it, and you can see there is a quite powerful. They are running some Context A33, and there is a CPU.
It's quite powerful, but it's not crazy powerful.
Yeah, not
so the thing, I mean, obviously the first thing people are going to do is compare this to a Raspberry Pi.
Yeah, exactly. Yeah.
Raspberry Pi is using much more powerful processor. So this is a A53, which is like a mid-tier application processor. Raspberry Pi is going to be A76. Probably, so this is 2 gig of RAM. There's a 4 gig model coming, and you can get a 2 gig Pi, but like, seriously, I don't use less than 8. Yeah, I don't use less than 8 gig. 16 gig ideal. So this is more like it can do Linux, but it's not. If you're expecting the same experience with the Raspberry Pi 5, where it actually kind of is a pretty powerful computer that can do pretty much the same things as this computer, it's not quite there. It's more just you can run Linux. They call it the dual brain. You know, you got your Linux over here, and you can run Python and shell scripts and things like that over here. And then you've also got your real-time microcontroller. And I think kind of the clever thing is how they make those work together. Because you could do that with a Raspberry Pi. You could get a Raspberry Pi and shove some other stuff on it and, connect via serial, I2C, whatever, and have them talk to each other. But this is already all built in. And, we can talk about stuff like that. But if you never program stuff, like you don't know what any of that is, but it just kind of works seamlessly with all the little bits of application software that they've created to kind of glue it all together in a way that you don't have to understand what's happening underneath
Yeah, so how about the power consumption? Like, I have to say that, to be honest, when Pi 5 they launched, I feel a little bit off in a way because they require more power and then they're using this kind of like non-standard power.
That's really interesting.
And how about this one then?
I haven't really analyzed that, and I don't know how much they care about that for this one because I mean Raspberry Pi, it started out for projects and stuff like that, and now, like you said, like the Pi 5 is like a beast.
Yes, exactly.
It's not like a maybe Jetson Nano type power consumption. Like that's not anything you ever want to run off a battery, Whereas a Raspberry Pi, a big enough battery, you can run several hours perhaps. So I don't know what the power consumption is like with this one. That's actually really interesting.
Try later.
Yeah, we can try later. But actually, what I did some experiment on it already. I found that it's not much. It's not very hot, so I can guess that it is. I didn't measure on how much power it is using, but I think it's much less power than the Pi compared to Pi 5. Yeah.
Okay, that's a good point. Yeah.
And actually, what David mentioned is that it reminds me our previous project, like some of the colorful tower. We are doing some setup, like we are running Raspberry Pi or Jetson Nano, and to work together with Arduino to drive the LED strip that we can go into our project. We are actually using the Jetson Nano to detect the people, what they are dressing. They are dressing in red, and we will turn the LED, the whole tower into red. Dressed in green, then we will turn it into that. And I still remember when because that project is in UK, in Bow Museum. And then everything I'm doing the support remotely. When I ship the Jetson Nano and we are using ESP32 to UK. Then what I need to consider is that if their program is a problem, how can I reprogram? Do the remote testing. Then so we do some reverse POSIT to log into it. That is using Linux because without Linux I cannot access to it. Okay. Another part is that how can I program the ESP32? So this is a quite challenge because I need to install the Python IO and compile the Linux program. But the Arduino program and flashing the MCU.
I think back then we also need to solder the ESP32 with one component which is
a capacitor. I need to add extra capacitor because they have some sequence on how to start the program. Get in the boot the flash mode. So I need to make sure every time I can flash correctly, I add an additional capacitor to make it the sequence is right.
So back then, our structure basically is like Jetson Nano communicate with ESP32 through USB, serial, which is mean USB cable. I remember we created a short cable inside for the whole, So it remind me the pain, to be honest. I mean back then I was like,
we also need to design the protocol, how they are talking together, but when I play with this new Arduino Q, actually the communication, they already have some built-in some
Yeah,
protocol.
I think they called it as a bridge, right? The Qualcomm communicate with the MCU. Between them something like a bridge.
There's a couple special terms I would say with the Arduino Uno Q, and one of them is that bridge. So basically, the ESP32, sorry, the ESP32. That's what you guys were using. The STM32 and the Dragon Wing have this bridge between them, where basically there's an API that exists between them, and so they can just talk to each other, and basically you can write in Python on the single board computer side, say do this, and you can write in C++ on the microcontroller side, and to pass data back and forth, and even like call a function. Like if you have this function in Python, you can just say, hey, I want you to call this function in Python from the C code. Yeah.
As much more efficient in that way because they having this.
They integrate all together already.
I mean, think about everything they're doing is maybe someone's never programmed before, let alone like understanding all these concepts we're doing. So, they got to make it so easy.
True.
Yeah.
So the beginning, beginner who want to code something like that, they don't need to get their hand into like C++, that kind of thing. They only focus on Python and then have the same experience to using the MCU to do this kind of rigid task.
But even if you're, I think they have this specific path of like, it comes with a bunch of examples, you play around with them, and then now that you've seen how the examples work, you modify them and you're like trying to make them do something a little bit different. So in that phase right there, maybe you're messing around with the bridge a little bit because you've got your own ideas. I want to add a new function over here, and I'm going to add something into the Arduino side as well to call that function, or vice versa. But again, you don't have to, for example, understand the concept of an RPC call like at all. It doesn't matter. You just know that they're doing some kind of interface together, and this is how you type it into the code, and it works.
Okay, cool. I think right now, we should get our hand dirty and then just get down to like see how this works.
Okay. Well, actually, I already complete most of the setup.
Oh yeah, and I think for our audience here, a little bit confusing, probably a bit confused. How this structure, So how we should set up? The first time you just mentioned how set up.
Well, yeah. So when they sent me this board, they just sent me the board.
Yeah.
No documentation, no explanation, anything. I didn't know what it was. So I just thought it was a microcontroller, and I didn't know really what to do with it. And then it was so early that I got this board, the documentation wasn't ready or anything. They were like, we can't send you the documentation yet, it's not ready. So then like I was just trying to figure out stuff to do with it. And so the answer was, plug it into a USB hub. Because obviously Raspberry Pi has HDMI, USB on board. This has nothing on board, it has one port. So I'm like, well,
So we also have the USB hub here.
So powered USB-C hub.
Yes. And the USB hub had to have HDMI output so that we can see what's going on, and also USB, and hub. Yes.
By the way, look at the cute little animation that's happening there.
Okay. and then, well, maybe Kevin, you can explain what is going on here.
Okay. So we can see that the HDMI actually plugged it into our Mini-KVM, our Openterface Mini-KVM. And Openterface KVM is connecting to our laptop. And there is another target USB is stimulating the keyboard and mouse. And then we can use our computer to control the Arduino and get the HDMI output from it. Let's have a try.
Let's get started.
So like I said, when I was first trying to get this board to work, this was really helpful because I didn't need to. I had my laptop and I didn't have to like find another keyboard and another mouse and plug them all in, and so being able to use everything from my laptop, super cool.
So you can see that there is a Arduino App Lab launch. Okay.
So this is the other kind of big announcement. The hardware is obviously very exciting, but none of this could really do anything without the App Lab, which is the new IDE. There's still the Arduino IDE 2.0. But then separately, there's this new App Lab, which has all the pieces required for this more advanced board, as opposed to the old IDE is just for programming microcontroller. But this does a lot more.
This is programming on the single board computer. We can see everything is there is my apps and example, and there is bricks.
Okay, let's talk about bricks real quick.
Yeah.
So again, this is much more complicated than a traditional Arduino. But even with a traditional Arduino, you have libraries.
Yeah.
So if you're, again, someone who's not, just getting started with electronics, not like a super expert in this stuff, and you want to interface with some other component, you don't really have to understand anything about that component because somebody else has already written a library, and all you do is type whatever .start and whatever .read or things like that to use that component. It's all been abstracted away, so you really hardly have to understand what you're doing. You just have to understand the interface.
Yep.
And so these bricks are the same kind of idea, but for the other advanced topics that are involved with this board. So another part of this, Qualcomm acquisition, I think, is they also acquired Edge Impulse, who do a lot of machine learning on embedded. And so I think they want to make that stuff easy to use. And so, Edge Impulse makes stuff very easy to use if you are an embedded engineer and understand how, those concepts. But I mean, I'd say they also do a pretty good job if you're just a complete novice and just trying to figure this stuff out. But it's still quite a lot to take in. If you see this board for the first time and you're like, oh, I want to do face detection, and then I want to do, make something happen on this thing when it sees a face and things like that. So it's a lot of different really kind of advanced topics all happening together. Yeah. And the bricks kind of say, well, don't worry about how face detection works. We'll just tell you if we see a face and you do whatever you want with it. And you don't have to train the model and understand the API. And, with Edge Impulse, usually you download the Arduino library and integrate that into some other code. It kind of abstracts all that stuff away. And not just, I'm using the example of AI because that's something they're heavily promoting. But so, for example, one thing I think is really cool is they have just a web server brick. So now all of a sudden you have a web server. You don't have to understand how it works. You don't have to know what Apache is or whatever they're using for it. You don't have to really, maybe you have to do a little bit with the HTML and JavaScript and stuff like that to make it work. But you really don't have to understand the entire server underneath it. And so a lot of the examples will use a web server and give you a web interface, which I think is really cool because you're remote accessing into this thing. The web server's on here, but how do you get to it, The answer is you've got a browser on your regular computer. It opens up whatever the IP address is of this device, whether that's on the Wi-Fi or going over serial. And now you can talk to this over a very nice, simple, attractive web interface, which you could do that on a microcontroller, but trying to put a web server on like an ESP32 and stuff like that. It's possible. Yeah, it's hard. Yeah, it's not. And this is just choose that brick and you're done.
It sounds like it's an all-in-one library that you can easily to play with this board.
Yeah. Okay. So what from me is that the brick basically is making the beginner easier to see those kind of advanced feature we can play around. Most of them probably relate to AI or what.
Yeah, I mean, there's AI, there's the web server, there's databases, there's any kind of because it's basically, not always, but a lot of the cases, Docker containers, right? So think about something you'd use a Docker container for, and this is just like a fancy wrapper around a Docker container, really. But they don't want to know what a Docker container is. They don't need to know what a Docker container is. Just they want to do a database. So here's a database. Don't worry about how it works.
So in a way, they can build stuff even more efficient because you don't have to know how the server work or know how the face detection. You just basically like calling API and then give me the data back, and then you can build whatever you want, easier. And but the problem is once I see the effect, and if I want to study deeper, and how it's still not a black box here.
I mean, it's definitely not a black box. I mean, everything's open source, so it's the openest box you can have. And I think that's kind of the idea of the approach is comes with all these examples. It's a lot to understand. So you're just like, I don't know how to do this. Press a button, it does an example with one click kind of thing, installs everything for you, you don't care how it works. Oh, look, it's detecting my face and making a smiley face on the board or something. But then all the code is still there. So it made some kind of Arduino sketch, and you can dive into there and be like, oh, so it's doing this to control the LEDs, okay. And then on the Python side, oh, so this is like the name of what I'm really doing. And then I think the idea is you take those examples, you start mutating them a little bit, exploring them with your own ideas, and then you kind of develop the expertise and can go as deep as you want into them, honestly.
Right. Kevin, shall we see the actual demo here? Like run an example?
Yeah, sure. So actually, there is a many example is here. So I choose some of them is quite interesting that is easy to show as a showcase. So for example, the Toggle Uno Q.
Some of the examples require extra accessories too.
Yes. So for example, for the camera, but for this one is we just try to toggle the LED.
Yeah.
But anyway, I will actually I want to run it in my laptop one.
Yeah, so let's point out a couple new terms here that are important. So we were using this in SBC mode before, where you are connecting to this as if it's a computer. We're using a laptop, but because we want to use the Openterface Mini-KVM, but we didn't have to use a laptop. We could have just had a mouse and a keyboard and a monitor right here, no other computer. So we were doing that remotely via the KVM, but now we're going to do something different. Now we're going to actually connect to the board with App Lab running on the laptop instead of App Lab running on the device.
Yeah. So now I'm going to use the Arduino Lab Web on the computer.
And so we're doing it via Wi-Fi?
Oh yeah, we need to set up the Wi-Fi first, so we can go into the. I already connect the Wi-Fi.
Okay, so we are just back to what we left, and David
I had to run and do some official duties to close down Maker Faire Guangzhou, and that gave you guys a little bit of a chance to figure out what was going on with their networking.
Yeah. So we have some sort of network.
Finally, we found that it's a network problem because we connect to the Wi-Fi in this environment, in this building, and because of it's closing the Maker Faire event, and too many people go into the same room, and then because of the Wi-Fi signal is too weak, and the Arduino Uno Q and our computer cannot communicate.
Okay, so how we solve it?
No, we just start a hotspot in my phone.
Okay,
and
use your iPhone.
Yeah, use your phone to open a hotspot, and then they are talking quite well.
Okay. So could you continue show the demo? Maybe you just show us the interface right now. How?
Okay. Let me start the recording again. I forgot to start the recording. Okay, no worry. Okay, then. So you can see now is already the Arduino already connected.
So we're using the App Lab on your laptop.
Yeah, this app is on my laptop.
Via Wi-Fi.
Yeah, via the Wi-Fi. And also this is Openterface. It's working quite well.
Yeah.
We just have one example of the toggle the paint, and actually what I want to do more is that I want to have a look into what is running on that.
Awesome.
Okay, so maybe here we are using htop. There is a built-in command is showing us how is the memory and CPU usage. So we can see there is a 4-core is running. The memory is 1.7
Okay. Yeah. Another interesting thing is it says it just went away, but it was showing the desktop environment.
Yeah, the document at the X-Oct. Yes. Okay. And on the other hand is that I want to do some checkings, like for example, I need to check what is the OS is running on. So
So we know it's Debian.
Yeah,
I believe it's the latest version, Trixie.
So okay, look at it. There's a Debian.
Yep.
It's
15.
15. Just it. Okay, and also we can have a look on what is let me do some command. Is that GCC running on it? Because the developer will use the Openterface to copy. Okay, you see the GCC is.
Hey, you should point out real quick what you just did, because you just copy and pasted from your computer onto the Arduino with your KVM.
Yeah, with my KVM, because we built in a copy and paste function. Yeah.
Basically emulated the typing behavior.
That's awesome.
Yeah. Okay, let me double check the kernel as well. Now you can see there's a copy and paste. I can paste from host paste. Okay, so it is 6.6. Yeah, 1.6. Yes, this is
Recent.
okay. Good. Okay, one more thing is that we want to continue to do the testing. Now, at this time, I already put in the web camera.
Cool.
Yeah, the camera I put into this USB hub, so we can try something for the AI. Yeah.
So a lot of the examples require additional accessories, USB camera, USB microphone, and then one thing we didn't mention earlier is this Modulino port on here, which is the same as a Quick and Stemma QT port. So Arduino has their own little line of things called modulinos.
Okay.
So if you want to add a temperature sensor, accelerometer, whatever, there's just a little board that you plug into here and you can daisy chain them, and a lot of the examples require those as well.
Okay, that is an additional accessory for the Arduino.
Right.
Okay.
Yeah.
Okay, good. Okay, now let's go to the face detection camera.
Okay.
We can start with this example. Okay, run. Okay, you can see is there is a container running. So I'm curious, what is doing now? You can see there is a run init, and actually, let me show with the Docker PS. What is doing? Oh, really? There is a Docker running. There is a Docker container running. We can see there is a video phrase detection.
EI edge impulse.
Yeah. So we know that actually the program is running on the Arduino Q Docker container. Okay.
Okay, this is cool.
Cool. So we can see this face. Okay, we are looking at the face. Oh, it can detect the two people face. Yeah. Right. Okay, it's quite fast.
Yeah.
It's quite responsive, yes.
And so this is the Linux application processor coming into handy, because the STM32 maybe could do a little something, but not
It
like
need the CPU power to run this kind of example. So okay, let's go back here to see. We can see how about the CPU is using quite a lot already. The four core is running, but it's enough. It's enough quite fast. So okay.
So I can see this setup. The advantages of this setup is that you can see the interface. Yes. At the same time, you're using the App Lab.
Running the desktop.
Yeah, everything in one console basically right now.
So we can switch it quickly on our laptop.
Right.
So this is very, very useful for debugs, especially for us like the developer want to try to look in. What is tell the log and go deep into the OS to look at what is happening.
Yeah.
Okay. Then let's stop this example. We can stop it. Stop.
By the way, I just realized this example is pure Python. It's not doing anything with the microcontroller.
Yeah, it's not. We can go to look into there is the example that we can see their source file. So you can see there is a Python. The main. Sorry, I go to the wrong one. I go back to the face detection camera.
Yeah.
Okay.
Oh, it's just Python. Yeah, no script. Yep.
Yeah, the Python you can see. How many lines? Only 33 lines of code. And then we can run face detection and open the web browser, and then you can do the quick.
So that's the brick for you, right? It's doing all that stuff for you. All you have to do is say, "Hey, brick, do the stuff."
Okay, and then I can just call perhaps the LED lights showing like how many people got detected, how many faces, one or two here. I just everything is just Python. It's already done. Yes, and then this kind of structure, the efficiency is still quite good because you communicate with the MCU directly, and then you don't have to do.
Yeah, but this is running on the pure not the Linux. I think if you need to control the MCU, maybe our Beam example is doing that. Maybe we will come to it again later. So, but interesting that if we look into the code, this is using there is no face detection. It's using an object detection, but it detects on the face, which means maybe we can change on
Yeah, change it to dog or something.
other things, pay people detection or maybe laptop detection and
Yeah.
something like that. Okay.
They should have list of the
Definitely.
object it can be detected.
I guess there is it.
Yeah,
So,
okay.
but I think that document will list it. I tried to search it this morning, but I cannot find. But I believe it will be listed. There was a list later.
Again,
Yeah.
remember, like this
This is
isn't
for
released
early
yet,
stage,
so a
yeah.
lot of the documentation, if you try to go to it, it's not even there yet.
Okay, good. Let's go to another. Oh, by the way, let's do the Docker PS again. To see if. Okay, you can see.
it's done.
I just stop it,
Yeah.
and then I can see that the Docker stopped. Yeah, the Docker container already stopped. So we try another example. Okay, this time I'm trying to more general stuff. Detect object on the camera to see what can be detected. Okay.
So this is using the video object detection brick and the web server brick.
Yes. Let's look into the source code again. You can see also the Python.
Pure Python, okay.
Yes, this is
27
even
lines of code, including four
yes,
lines of just
yes,
the license.
Yes, and you can see there is the detection. Okay, it's just using the video object detection again.
They
and
didn't
then,
say face or anything
yeah,
because they
this
want
is
all
thing.
objects.
Yeah, all object. And let's see. Okay, it's run and populate. There's a.
Oh.
What's the green things showing?
It was thinking this was a time.
Okay. But
only
it's
50%.
Yeah. Okay, person. Wait. Is it the phone? Can you detect the phone? Hey, sorry.
No,
So
maybe get it away from my face.
or maybe I can turn on the
screen.
the cell phone. I need the screen need to on.
Yeah.
Okay, because it's
Okay. Maybe plant or something.
Bottle of water.
bottle.
Bird
Bottle,
person.
yeah, bottle. So you can when it detects on more than face, and actually it still works quite. It's quite fast. Yeah,
Pretty high
yeah.
frames
Okay,
per second.
okay. Go back to the CPU again.
Wow.
Okay, you can see it's similar. It's similar to the face detection. I think it's quite efficient for writing code. Just 27 lines of code.
Yeah, I mean, and also, the edge impulse models a lot of the time are running on much more constrained CPUs than this. They're mostly designed for things more like the STM32. So this is like luxurious probably for their model.
Okay. Oh, let's finish this example and we try something more interesting. Yeah, we can program on the SBC to see how it works. So, for example, we use the program from the Arduino website. Let me sort the example first. Okay, it is solved. Let me double check on the
Docker PS to make
Docker
sure it's
PS.
true. Oh,
It's still there. Oh, it's running too. It is running on the general object detection and actually running too. Anyway, I try to stop it. I try to stop it here to see is that running? Oh yeah, it's running.
Okay.
And I try to stop it. Stopping it. Okay, I don't know whether it's stopping. I just.
we do know.
We don't know.
Still,
One of it stopped, but another I don't know where it goes. Where it comes, it's still running.
I think it's just taking a second. I think it's gone.
Okay.
Yeah, it's right now.
Try that again. Okay.
Yeah.
Everything gone. Okay. Then let me go to. Billy just mentioned about how to control the MCU.
Yes.
Yeah. By the
Yeah, the other examples were pure Python. It's not even using the STM32.
Okay, let's go
Now we
into.
can see the bridge in
Okay,
action.
so for example, I go to the print example to see.
Is this the same one we did earlier?
Yes. It's go into the user menu.
Oh, I see. Sorry.
Yeah, the user menu. There is some example to running how to control those print
With the bridge from Python?
With the bin. Okay, so for example, let me see how to control the LED. I search the LED. Bring LED. Okay, LED matches and LED. Tunable LED, RGB. Okay, I just try to run the RGB LED because we can see. Okay, you can see there is a command line. We can just echo 1 to a specific path in the Linux.
Yeah, let's explain this real quick. So in Linux, like everything is a file, right?
Yeah.
So like an LED is just a different kind of file.
Exactly.
And so what you can do is with the command line, you can pipe a 1 into there, and you're like writing to this file, say turn on file, or you know. And
yeah. So this is quite low level. Let's try it to use our Openterface.
And this is also similar to how you would do GPIO on a Raspberry Pi.
Okay. We can just paste it to it.
Yep. So we're saying put 1 into the LED file, red.
Okay, red.
Oh.
I need the sudo. Yeah. I need to type the password. Okay. You can see the red light.
Okay. Here.
Okay. The red light. I can turn it off. Just echo 0. Echo 0. And you can turn it off. So you can go back to the command. You can see echo is the red. Let me try to see that. Is that green? Okay.
Change it to a 1.
Change to 1. To 1. Okay, there's no green.
No, it's good.
Hey, it's green. It's green. It's running. Okay, and turn it on. So in this showcase that we are running control the board, we don't need to use the Arduino IDE already. It's using some command line directly from the Linux.
So you could do like a bash script.
Yes, yeah.
And we're showing the LED, but it could be any of the GPIO.
Yeah. Okay, let me go back to the website to see how to control the LED. Okay, you see there is this is a Python. It's a Python controlling, and also the Arduino. So maybe we can try the Arduino first. Yeah, because we are trying to do some. The example will show it is just like some beam, but it is using the turn on the red GB on, RGB on, and RGB off every seconds.
Yeah.
Okay. I just copy it, and this time we need to go back to Arduino because I don't know how to compile in the.
You could do it with the Arduino CLI. You could technically put something into a script and then use the CLI to build it and flash it. But
okay, maybe we just try to create a new app. Okay.
I mean, the IDE is doing the exact same thing. So if we monitor in the logs what the IDE is doing, we can see what the CLI commands are.
Yeah. But if we need to, because I open it.
Make the script, and then just when you say build and run, we'll be able to see exactly what the CLI commands are that it's using.
So you can see here there is a sketch. I just open the sketch, copy. Copy everything here.
And what's in the Python? Nothing? Is it blank right now?
The Python is, I think, this is a new project, so this is empty, just a hello world. So there is, you can see the file structure is that there is a Python folder and a Sketch folder, so they split into two.
Yeah.
Okay. So we are now using the Sketch.
Do you want to look real quick and see if there's anything with the YAML file as well? So no, the sketch.yaml.
Okay, this one.
So this is how the two will communicate. I believe. I think there's some stuff that gets generated into here.
Okay.
Once we add some bridge stuff, I think we'll see some more stuff popping up in here.
Okay. You can see the dependency. They are using some debug log, message packs, etc.
So when I was saying about the CLI stuff, the FQBN here is like the board name, fully qualified board name. And so these are actually things that's just going to send directly to the CLI.
Yeah, I think essentially we can have run everything in the CLI, but I think we have the Arduino Lab.
Yes, I mean,
this is much easier.
Obviously, I'm just saying.
Let's try to run this program.
Yeah. When we were talking about we could do it from the CLI, we're going to do it this way because it's easier, but it's technically absolutely possible. All this is doing is a nice interface over the CLI.
Yeah. But if we want to run it offline, maybe we need to do it at the script. In the script, and we need to go back to the terminal to run it. Yeah. Let's try to run it, okay, to see what is happening. Okay, you see compiling,
Yeah.
and let's go to
So
C.
that's literally just the CLI output.
Yeah,
there.
yeah, yeah, and you can see the Arduino. It is what it's doing. It's doing. I think it's
GCC.
you doing some compile. So it is compiling on the SMB on the Linux. It's not on my
Right. Yes. Your
my
computer's
desk,
just
yeah.
observing.
Yeah, they're computing on this single computer. Okay. And you can. Okay, is that everything done?
So that's something I've definitely done before as well, is set up a Raspberry Pi with the CLI, with the Arduino CLI, and I'll have like a headless Raspberry Pi with an Arduino connected to it that it can flash. You know, you guys were talking about earlier, like that remote management in the field type stuff. So now this is all happening in one pre-made.
Yeah, because if you have a two setup, one is the MCU and another is a Linux, a single
sort of a
you need to
supervisor.
you need to make sure everything connect right, and this one all in one.
Yes.
We don't need to worry about.
Yeah.
Yeah. You can see this is already running. It's running.
Oh, yeah. So there's our
running.
blinking happening. Yeah.
Okay.
So every second it changes.
Yeah, and I can see that from the top. You can see the CPU.
CPU is nothing.
It's
this time.
nothing. It's nothing already. Let's have a look whether the Docker is running as well. Docker PS. Docker is nothing.
Yeah. And honestly, the CPU that is using is probably you right here looking at it. It's not even using the CPU here because it's just all on the microcontroller.
Yeah, it's MCU is running that, so we don't need the Linux CPU time. Yeah.
So for those kind of low-level job, I mean,
Yeah, just hand over to the MCU to do that. Yeah.
But also, we could have just used an old-fashioned Arduino if that's all we wanted to do.
Yeah. Okay. Okay. We can see from this example that there is a Python. There's a Python script, but I want to do it differently. I don't want to use the Arduino LD. I want to do it directly on the single board computer to see whether it works or not.
So this is using the file-based notion as opposed to the other thing we talked about was using the bridge. So we're not using the bridge right now. We're just using regular Linux file style GPIO.
Let's have a try. Let's have a try. Now, let me stop the case first. Okay, it stopped quite fast because it's not using Docker. Okay, I copy everything first, and then I go to my Openterface. Then I do the vi led.python. Okay. Or maybe I need to set the.
You gotta do the no paste.
Yeah, I do the but this is pasting the code.
Yeah.
So I need to make sure that everything is working fine. Is because there was an indent to auto it. I will try to prevent the VI doing that. So I need to set this mode is set pace. Okay, and then I will go back to the browser. Where's browser? Browser here. I copy this again. I copy all the code. You can see all the code here.
wait, whether
I don't know. I don't know work or not. Let's see.
long.
It's trying typing.
Yeah, move the windows a little bit. No, I mean the little block. Yeah.
Okay. It's trying. It's working quite hard.
Yeah.
It's kind of like someone controlling your computer or something.
It's typing. Anyway. Okay, finished. Right. Okay, let's save. Save this program and try to run it.
Are you gonna need sudo for this?
Okay, you remind me because this is controlling the low level. Yeah, from low level. So you need to run the Python. LED. Okay, is that running? Oh, what? It is running. So you see, we can run the program without the Arduino IDE. So if we, for example, if we want to make it to run standalone, just controlling like our previous project, the colorful tower, we don't need the computer.
Right.
And just make it in the startup suite, power on, and then it can run.
So this kind of structure does make development for such as Linux plus MCUs much easier in a way and stable because they have built-in bridge each other, and I think it seems much easier compared to previously. Quite often we have to like
More
have
efficient to
Linux
writing code and troubleshooting, and you see the program is just set the LED on and off. Although this is quite simple, but I think once we install the fast LED onto it, and it can run the same as what we did before. And also it built in some AI. You can detect on the peoples and the crows just very easier to just extract from the people. Okay.
And what is the price then?
I believe it's $44 or 44 euros. $44.
$44 is actually.
Can we have a look on here real quick?
There was a pre-order.
Yeah, you can pre-order. I think it comes out later this month. It's probably just right on the Arduino homepage. If you just go to arduino.cc, it probably is at the top of the page there, I'd imagine. They're probably promoting it pretty
I think it's quite competitive price.
Yeah, if only $44, I think it's quite good price still for beginner.
cheaper than the 2 gig Raspberry Pi.
Yeah.
And you get all the other stuff as well. Again, it's not as powerful as CPU as Raspberry Pi, but it's a different idea. Okay, so this is 47 euros. Maybe that's for shipping or something. But
It's already in 3
3
to 4 weeks.
oh no, change the country. The thing where change that to US.
Yes.
Now see what it says for the price. 44.
Yeah,
it says
44.
44.
Right, great.
Yeah.
I mean,
Yeah.
I would like to have one, to be honest. I mean, it's make life easier if we want to do some quick, build for, some.
I think there is many possibility to build on the project like we previously does. Use those side of Linux to control the complicated logic, control the robot arm, LED, and the motors. Those kind of things is very good.
Especially because don't forget, it's the existing, the original form factor. You can put any of your old Uno Q or Uno style shields on top of it, and then, taking a peek at the future, there's the high density connectors on the bottom for a new kind of shield that will be coming soon, I think.
Yeah, so I can see that for extension board, there's quite some, potential here. Maybe someday we have time, we might think about how to use those.
To make something.
So I think the Pro line, some of the Pro, the Arduino Pro have the high density, high speed connector like this. I don't know if it's the same compatibility, but I think that's kind of the idea is, traditional on the top and then future on the bottom.
Cool. Okay. And I can see that in this is fundamentally still a good hub for study, like for education, for STEM,
I think that is the primary target.
The Arduino is target for the education. I think now it's going to more engineer, developer who will like this kind of small board.
And with such a high level chip like running Linux, which is able to run AI detection, that kind of thing easier with the brick and
Maybe in the future we have opportunity. We will try more advanced like fast LED. And actually I found that for the AI, I go into the Docker already. They are running YOLO. But I think these two, they're running YOLO. But I didn't know which version is using. Or maybe we can train our own YOLO. You still remember some of we trained out to detect those kind of charges or in our previous project. There's many interesting things that if we can do more on that.
Okay, great. I think we have covered most of the juicy part of this Uno Q. And any note you would like to add for this video? Like, what do you think?
Well, I think this is amazing product. I will buy one. Hope I can get it as soon as possible.
We should order now.
Yeah. So this is the comment from engineer, our Kevin tech lead. So yeah. So and also like the price.
Yeah.
Great. Yeah.
Yeah, I mean, so obviously, I think part of what's happening there is it's the Qualcomm partnership. No, sorry, the Qualcomm acquisition. So I'm sure that they are, it's not like they have to buy the chip anymore. Qualcomm just wants to get this out there, and so I'm sure that they're able to really bring that price down. And like we said, it's cheaper than the cheapest Raspberry Pi, and not maybe as fast, not maybe as capable in terms of computing brawn, but it's got a bunch of other extra interesting things on there that make it kind of just, a different thing that we don't need to compare directly to Raspberry Pi that is, the next generation of Arduino.
Yeah. For me, I think with their on board, hopefully they still can keep this open source and make it easier accessible for beginner to get into electrical world and even right now AI things. Yeah, so great. So I think this is what we have today, and hopefully see you guys next one. Yeah, so bye.